Hey guys, last time I talked about Haskell, and this time I'm going to talk about a programming language that is even more obscure, and that is Prolog, which stands for Programming Logic, which already gives us a little glimpse what it is probably about. I learned Prolog mostly through the tutorial learnprolognow.com, and that is because our professor at Trinity College Dublin, where I'm currently doing my Erasmus, just was probably just a bit lazy and used that tutorial. It's very basic because you need a long time to actually get used to the language and the logic, even more so compared to Haskell. And that's what I'm going to cover today as well. Very basic concepts and some examples. And there are basically two reasons why you might be interested in Prolog, why you might watch that video. Like if you want to get started with Prolog, like one reason could be that you simply like the idea of it, because so far you've probably only seen Java, C++, Python, etc., which basically are all imperative, use the same logic, and Prolog is very different. So if you're interested in how diverse programming languages can be, try out Prolog, just have a look. Or second of all, if you're interested in natural language processing or knowledge databases, that might be something for you from what I've heard. What's the application of Prolog? But if you're already that interested, you might also already know more than I do. A third reason that is definitely not a reason to learn Prolog, as far as I can tell, is to have like great skills on the job market. It might be nice on your CV, but it's not, generally speaking, nothing that is highly used in the industry. It's a funny thing, and it can be used in NLP, but that's it. So I would say let's dive right in. I'm gonna go into the Prolog environment that I used in class the last month and weeks. And we are gonna look at some basic concepts and some examples, like I mentioned already. Let's go, guys. Okay, now we are in SWI, my Prolog environment that we used in class. And more specifically, we are in the editor here. And before we actually explain Prolog, we will make a really quick recap to you, probably one of your first mathematics classes at university. Or if you don't have any background in STEM subjects, or like math, engineering, whatever subjects, I hope I can explain it a little bit here quickly. So in mathematics you have this concept called relation, and it's simply like a collection of pairs or like a number of values. For example, we might have this collection of relations, and so on. And what we do with it is we interpret it as humans normally. If we do computations or stuff, we say this is a love relation, let's say friendship. Let's keep it innocent. Friendship relation. And there's a lot of stuff in there. It could also be more like, it could be a parental relation, then it would be like a parent-child relation, then it would be three elements. Mary, John, and the child, for example, is named Max, and so on. So that's relations. And then in mathematics you introduce a second concept after this normally, and this is functions. And functions are a specific type of relation, and you normally don't think about functions as relations, but they're just a relation where the first component, normally it's the first by convention, can only occur once. Let's say, for example, the relation, this is our relation, and this would be the relation between like a number and its square. And the number 1, 2, and 3 can only occur once, because if we had this in there, it wouldn't be a function anymore, because it has to be deterministic, meaning that you can, if you have an input or like an x value, normally you call the first one x value, you have to know what the corresponding y value is. Usually you write it like that. F of 3 equals 9. So, and normally programming languages like Java and all the others basically are about functions. They define a function. You have a set of inputs and then an output. But Prolog is different. Prolog is about relations. And what you can do is, instead of asking what is the output if I give you that input, Prolog answers the question what relations are true, and true means in that sense what relations are in your database or in your program. So for example, if you write a program or a database in Prolog about the love relation, defining who loves who, or like, let's say friends, let's keep it with friends. The friends relation, who's friends with who, with whom, etc. Then you can ask Prolog two basic questions. First of all, you can ask whether a relation holds true. Is Mary friends with John? And Prolog can say yes or no. Second of all, you can ask who is Mary friends with? And Prolog can give you all the answers: x equals Peter, x equals Max, etc. So that's also the difference between relation and function. And with a function you could only get one x. Here you can get several. And that's basically all it is. So when you write a Prolog program, you just define what relations hold true. And you can either do this explicitly or like by just like literally typing friends, Mary, and Peter. You would write it like, literally you would write it like that. There will be a valid Prolog clause. Up there, that line is not a valid Prolog clause, but that one is. Or you could write it implicitly by saying Peter is friends with someone if X is rich. You can already see how it highlights stuff here. For example, that would basically mean that Peter is quite a superficial person, and he is only friends with people who are rich. Yes, so that's like the mathematical background of Prolog. And its origin is from what the professor told us, and also from what you can basically deduce from the name, is that you want to have a very mathematical language in some sense, where you just state how things are, and then it logically deduces stuff. So it's very close to mathematical reasoning in a way. That's where the name comes from, programming logic. I have to look it up if it's really correct, but that's it. Okay, now we move on to some examples and more like actual programming stuff. Okay, here we are with our first example program in Prolog, and we are just going to look at the first 3 lines. The very first line is called a fact, and we have a relation, what I introduced earlier. In Prolog it's called a predicate, and the name of the predicate is wizard, and it is unary, meaning it takes only one argument, and that argument in that case is Harry. We ended with a dot, and that's already like the first thing to state. Harry is a wizard. Second one, the second kind of expression we can have is a rule. In this case, it's notated like this. It says X is a wizard if, that's this weird thing, if X has wizard genes. Both are again unary predicates, and when we, for example, want to know is Elon Musk a wizard, we can we go into this, we say we set X to Elon Musk, basically go into this here, has wizard gene Elon Musk, and see if it's true. We find this third fact, or this one here, and then we know that Elon Musk is a wizard as well. That's the two types of things you can do in Prolog: facts and rules. That's all. Very simple and minimalistic compared to other programming languages. Let's test it, how we would run that program. There, where we go into this little thing here, we can already see by the question mark that it's kind of about asking questions. So the most obvious question we can ask is Harry a wizard? And we will, oh yeah, of course, silly me. I forgot to consult the program or load it. You call it consulting because you basically want to have answers, so you consult something. Okay. Whatever. So here we are now again. We ask, is Harry a wizard? And we get the answer true. Ignore the false, but it's true. Then we can ask the second type of question, which is who is a wizard? And we get two answers. We get X could be Harry or Elon Musk. That's the two ways you can basically consult a program, either by getting a yes or no answer, or by getting all the possible variables that fit to your question or make it true. Then there's another concept that I want to explain quickly, and that is unification. I already explained it a little. Unification simply means that if you look, if you ask a question like I did, for example, wizard X, it tries to unify wizard, the term wizard X, with any of the below. Or let's say wizard Elon Musk. Let's say I ask the question. Let's make it informal here. Wizard Elon Musk. Prolog would simply do it as expected. It would, like as a human would do, well, as more or less would do. It goes from top to bottom through all the possibilities. It would test, does it fit that one? No, it doesn't. Does it fit this first one? Well, to see if it fits the first one, we would have to set X to Elon Musk, and then see what happens. So we then have to check, has wizard genes Elon Musk, and go down again through all the stated facts or rules and find that one here. So we know we don't have anything else to unify again, so we go back up basically, and we now know that Elon Musk is indeed a wizard. And this kind of trying to unify wizard Elon Musk term with others is called unification, or proof search if you go through it. So you do a proof search by trying to unify certain terms. That's unification. Then you have the concept of like recursive definitions, because otherwise you wouldn't get something like loops or iteration or anything like that, because you don't have it. Like I said, you only have facts and rules. You don't have while loops. You don't have anything like that. So we have our second concept here. We have a child relation. Here it's binary this time, and N is the mother, Bridget is the daughter. This example is, by the way, from the online tutorial learnprolognow.com. I'll link it in the description, just to avoid any copyright here. So we have lots of children and lots of parents. N is the mother, Bridget is a daughter, Bridget is also a mother, whose daughter is Caroline, and so on. So we have basically a descendancy line. family tree, or whatever you want to call it. And then you could also, of course, ask like, who's the child of N, or is Caroline the mother of Donna? Or you can also ask who is descended from whom, and that's defined here in those two rules. And that's recursive because as you can see, descent, we say that X is in some way, other way around, Y is descending from X if either it's already a child relation, so a direct relation, or X has a child set who in some way comes before Y. This might look a bit weird, but bear with me for a second. But generally we can see that it's recursive because on the left side there's the descent relation or predicate, and on the right side there's also the descent predicate. If we want to go through it as for example and see if the relation descent and Caroline holds true, we want to check that. We would first see is there a direct child relation or child predicate between those two? And there isn't. Anne and Caroline, nope. But we know that Anne is the grandmother of Caroline, if you look at it. So that's what our program is supposed to do. We go to the second rule and check if that helps us in any way. So we set X to Anne and Y to Caroline. We then look for we know that X is N, right? And set is, the variable set is not occupied yet, so we can fill it with any value. We go up and see with what value we can fill it, and it's Bridget. So we now know that X is N, Y is Caroline, as stated before, and we now also know that set is now Bridget because the child relation between N and Bridget holds. And then we want to see if descent Bridget Caroline is true, because we just stated that set is now Bridget and Y is now Caroline. So we check that. We go to the first rule and see if that applies to Bridget and Caroline. We have X as Bridget, Y as Caroline, and indeed the child relation holds. Bridget Caroline. So I hope that's kind of understandable, comprehensible. If not, try to make it slower for yourself and see if you can solve it. Yeah. So that's recursive, and you really change the way you think about recursion when you do lots of Prolog, because it's just so fucking different. And if there are okay, that was my landlord who came in, so I had to pause a little. But that is the concept of recursion. And now we will go to the last concept, and that is how Prolog deals with lists. And if you watched my video on Haskell, you can already recall that in languages that rely on recursion a lot, lists are defined recursively as well as having a head, which is normally one element, the first one, and having a tail, which is a list itself again. That's the recursive element of the whole concept, that lists consist of a head and an other list. And what does that list consist of? A head and an other list. How does it end? It normally ends, if the list is finite, with the definition that the empty list is as well a list. And the empty list does not have a head and tail. So the notation here in Prolog is this one here. It just says that here X is the head of the list and T the tail. And we define a predicate actually with it. So that's how you would actually calculate stuff with it. You say that there's a predicate memb, which means the member. And it says X is a member and the relation is true if the value or variable here on the left is a member of the list on the right. And it is true, of course, if X is already the head, then the relation holds true. But that's not always the case. But that's the easiest case, kind of. So you say, if we can look at the head, like you can only actually look at the head. The tail is still kind of hidden and not accessible. So you can look at the head and say, if that's the thing we are looking for, we are happy, and the predicate actually holds true. If not, if it's something different, in this case the variable h, I call it, then we have to look further, and we do it by cutting off the head and basically now looking whether x is in the tail, the remaining one. So we would cut off this head thing here and look in the rest. So if we have the list 1, 2, 3 and we want to know whether 2 is in there, we would first realize, okay, 2 is not equal to the head of the list, which in this case is 1. Let's say we want to know what I'm talking about is this one here. We would cut it off. So in the first step we would cut it off and then come to this. Oh, okay, I made a little mistake here. I meant 2. So we cut it off and then come to this little list. Ta-da! And then the first one applies, because in this case 2 is equal to the head of the list. And then we're happy. So we basically do it as long as we don't we do it as long as it needs, so that the head is equal to what we're looking for. And that's how you deal with lists in Prolog. I know this is all a little bit confusing though, because it's very unnatural if you're used to other programming languages, but maybe it sparked your interest. I hope you enjoyed it. I hope you'll have a look into Prolog. Like I said, it can be useful for artificial intelligence or NLP, natural language processing. It's super weird. Learn Prolog now. The tutorial online has some fun examples, like they use a lot of inside jokes about Pulp Fiction in their databases, or like yeah. It definitely opened my mind a little and made me realize how different programming can be, and how frustrating it can be, even more frustrating than programming in Java sometimes, at least for the first weeks. So yes, thanks for watching. See you another time. Next video will probably will not be related to computer science or anything technical, but instead it will be philosophical, or maybe about myself or something like that. You know, the usual stuff. Okay, see you around, guys.